Let's start this webinar on TraiNDE UT version 1.4. I hope everybody can hear me. So thank you very much for attending this presentation. I am Benoît Puel, and together with my colleague Raphaël Iglesias, we will be presenting the new feature of our training simulator for non-destructive testing. To improve your webinar, we advise you to set up Teams as follows. In the top icon bar, click on View, then Speaker. And we advise you to right-click on the webcam of Raphaël Iglesias that you most probably see on the bottom right side, and to click on Fit to Frame. Here is the agenda of today's webinar. We will start with a brief introduction about TraiNDE and our activities. Then I will present a TraiNDE product line. Next, I will give you an overview of TraiNDE UT and its features. Raphaël will then make a live demonstration of about 30 minutes. We will conclude with a Q&A session. You can ask your question during the presentation thanks to the Q&A icon. That's open a menu on the right side, and then you click on this button and click on Ask Question. Let's first present our activities. For those who don't know us, TraiNDE is a French company with a subsidiary in USA, TraiNDE Inc. We are the exclusive distributor of the NDE simulation platform SIVA, which is developed by the French Atomic Energy Commission. We also provide technical support and offer training courses on SIVA and on reliability in NDE. Additionally, we offer consulting. We have a dedicated team at TraiNDE for consulting services for our customers and high computation capacity. For instance, they can design probe, they can work on technical justification and qualification, offer expertise assessments, and so on. Finally, we have developed at TraiNDE a range of virtual training tools for NDE operators, which is our topic today. Let's focus on our innovative brand, TraiNDE. These products are an NDT simulator dedicated to training and skill maintenance. We offer two main products, TraiNDE UT for conventional ultrasonic and TraiNDE RT for radiographic controls. In the nutshell, because it's not our topic today, TraiNDE RT simulates the entire radiographic chain with X and gamma sources and display the image corresponding to the user-defined parameters, along with a report of the radiographic shot and potential mistakes. Because a picture is worth 1,000 words, let's first look at TraiNDE UT user interface. It has been designed as a flight simulator for NDT. The software runs on a touchscreen laptop, standing in flip-flap mode here, and an external tablet touchscreen lying flat on the table. It is split in 3 windows. On the tablet screen here, the digital mockup. It represents the virtual test piece to be controlled. The controller handles a dummy probe that mimics the shape of an actual MWB casing. The location of the dummy probe is tracked on the touchscreen on the virtual test piece. On the left side of the laptop, you can see the conventional device that is a virtual UT flow detector. It displays the signal at the dummy's probe location and orientation on the test piece. On the right side, the workbench displays the inspection 3DC. TraiNDE UT runs on affordable and accessible hardware, requiring only a basic laptop and a standard external touchscreen. The virtual flow detector displays the UT signal in real time based on the location of the dummy probe. TraiNDE UT comes with a pack of exercises, allowing controllers to practice from calibration and sensitivity to the inspection of plates and welds. 2 optional packs of additional exercises are also available. It is possible to customize the exercises and even to create your own. Finally, TraiNDE UT offers several educational tools, such as the zone coverage, the section view, the ray tracing. Users can also mark indication and display flows. The first version of TraiNDE UT has been launched in 2019. You can see what it looked like at the time. Since then, it has evolved with several updates. First of which, the indication marking. Next, version 1.2 added the device connected option. This is an electronic device plugged into the laptop with a USB cable that allows to practice with actual flow detectors. It works with all the flow detectors of the market. For instance, the Sonatest Wave, Olympus Epoch, GIS, USM-GO. The signal from TraiNDE UT is then directly displayed on the flow detector. And you can use all its features, like the filters, the calibration, the DAC, the gates, etc. Version 1.3 brought the exercise customization, the possibility for users to create their own exercises, and 2 optional pack of exercises. And finally, we have just released the version 1.4 that introduces the session management and 3D view, and significantly improved the user interface and experience. I now let Raphaël make a live demonstration of this latest version.
Okay, so hello everybody, I'm Raphaël, and today I will perform a live demonstration of TraiNDE UT to show you the new features of this version 1.4. We will begin by a quick presentation of the setup and the interface. Then we go through the inspection of steel plates. So we will see the calibration of straight probe, the verification of the sensitivity of the probe, and then we inspect the steel plate by using some educational tools provided by TraiNDE UT. After this first exercise, we will see the inspection of V-weld. It will be the occasion to show you even more functionalities. And I will finish this demonstration by talking about the administrator session to show you what you can do as a trainer. So let's start with the presentation of the setup. So as Benoit said, it is composed of a foldable laptop with a touchscreen, an external touchscreen, and some dummy probes. The laptop and the external touchscreen are conventional devices, very standard, that you can find easily on the market. The dummy probes, shapes like MWB and MSEB casings, are composed of tactile disc tips to allow the detection in position and rotation by the external touchscreen. The shape and the weight of these dummy probes are really close to the shape and weight of real probes. We will use them to practice inspection gesture. When launching TraiNDE UT, we'll see this window. So one of the main new feature of the version 1.4 of TraiNDE UT is the session system. We will talk about it later during the presentation of the administrator session. So for instance, we are going to log in as a guest. This window called the manager, from there you can select and launch exercises. An exercise starts with a calibration block, a sensitivity block, and a specimen to inspect. On the left side, you can see the list of all the exercises organized by categories. Here I have the full package of exercises. So we have calibration blocks, plates, welds, and blind blocks. The signals displayed are simulated, but a huge part of them are experimental ones. We have scanned a lot of real specimens to acquire experimental data to be as close as possible from reality. When selecting a specimen, you can see at the center of the screen the description of all the specimens available in the exercise. So here we have a V1 block and the step weight sensitivity block, which are both experimental blocks, and the plate to inspect, which contains simulated signals. Below, you can see the probe list. For this exercise, only one probe is available, a 4 MHz dual element straight probe. To start with the exercise, we click on the start button. Let's do it. So first of all, on the external touch screen is displayed the digital mockup. From there, you can select the specimen to inspect and the probe to use. On the left side, you can see icons representing menus. The first one is used to move around the specimen. The second one to choose the specimen you want to inspect. So here you have the list of all the specimens available in the exercise, as we saw earlier in the manager. So we are going to select the V1 block to calibrate our straight probe. Then you want to choose the face where you want to land your probe. I'm going to choose front. And the fourth menu is used to select the probe. Here we have only one choice, the straight probe. The other menus are used to enable or disable educational tools. We will talk about it later. On the laptop, two windows are displayed. On the left, the brand new flow detector. This flow detector has been completely reworked and modified to improve the user experience and to add new features. This flow detector contains all the parameters that you will find in any other flow detector of the market, such as the calibration parameters, the probe settings, the sensitivity menu to create DAC and TCG curves, the gates, and so on. By clicking on a menu, you will have displayed at the top of the window all the parameters available, and below the gain button, freeze and ecodynamic functions, and the gate measurements. On the right side, you can see the workbench, which is a 3D view of the selected specimen. So here you can see a 3D view of the V1 block, and by thanks to finger gestures, we can rotate the view, move it around, zoom in, and zoom out. This window is also used to display the section view of your specimen and the ray tracing of the probe. So for this exercise, I will use a dual element straight probe. So I have to change the pulsar mode of the flow detector. So I go in the probe settings and change pulsar mode to dual elements. Now, by grabbing my dummy-straight probe and landing the probe on the screen, I will display the corresponding signals in terms of location and orientation of the probe. So as you can see, when I land the probe, the signal is displayed, the corresponding signal is displayed, and if I remove the probe, the signal disappears. As you can see also on the 3D view, a 3D model of the probe is displayed, and it follows my move. So I know exactly where the probe is located on the surface of the specimen. So let's get started with the calibration. I will increase the gain, adjust my time base, decrease it to better see my third bottom echo. And now I will activate my gate 1 and position it on my third bottom echo. By double clicking on it, I can move my gate and restyle it by using the arrows. Now, by holding the gain button, I can automatically set my echo at 80% full screen high. Now I will activate gate 2 and position it on my third bottom echo. Let's add some gate measurement by clicking on the plus button and modify them. For the second one, I want to display the sound pass measured by gate 2. So I select gate 2 and I want to measure the sound pass. For the third one, I want to display the sound pass difference between gate 1 and gate 2. So I select gate 2, difference with gate 1, and I want to measure the sound pass. Now we have all the information to start calibrating our probe. So in calibration, I click on velocity, a panel opens, and I can here adjust my velocity to get a sound pass of 50 millimeters between gate 1 and gate 2. All right. Now I calibrate the 0 to get a value of 25 millimeters measured by gate 1. And now my probe is calibrated. So let's move on the sensitivity block, a step wedge block, to create a DAC curve. For the purpose of this demonstration, I will activate the first educational tool, which is the display flow tools. In the flow tools menu, we can activate display flows. And as you can see, represented by red dots, we have the projected view of the flat bottom holes within the step wedge block. We also see this information in the 3D view. As you can see, we have the 3D model displayed and located inside the step wedge. So I will decrease my time base now to adapt it because I know that my plate to inspect is 23 millimeters thick. I adjust my gate. And now we can click on the sensitivity menu, select DAC, and start editing my curve. So by triggering the flat bottom holes echo with the white gate, I can add a point, replace a point, or remove it. When you're done with the creation of your DAC curve, you can click on OK to save it. Now, below the freeze button, you can see here the reference gain value displayed. So we are done with the calibration and sensitivity. Let's move on the plate to inspect. So I select my plate. Here, to help the trainee to practice his inspection pass, we can activate zone coverage. So we add a zone. This zone will record and display the probe pass during the inspection of the trainee. So we can resize it. Okay. Sorry. Okay. And put it wherever we want. And now, by clicking on record and probe pass, we will see display in real time the pass of the trainee during his scanning. In green, the pass considered as good, and in red and white, the pass considered as not good. In this case, because we are scanning outside of the zone coverage. When the trainee is done with his scanning, we can stop the recording and display the score. Here, at the top left corner of the zone coverage, we can see that I have scanned only 31% of the whole area. The goal is to cover 100%. And as a trainer, you can check if your trainee has correctly scanned the whole area. It also helps the trainee to practice his inspection gesture. So I saw that I have an indication in the middle of the plate, so it's time to dimension it. So let's find the maximum amplitude of this indication. All right, and now we will dimension it thanks to the -6 dB method. To help me to dimension it, we will add some markings on the specimen. So in the flow tools, I can add some markings. I will change the reference of my markings by selecting index points. Like this, my marking will be added from the center of my straight probe. And now, each time the echo reach 40% full screen high, I will add a mark. As you can see, yellow cross is now displayed, and I repeat the operation. Okay, once you're done with your markings, you can link all your crosses, your yellow crosses, to create an indication. So by clicking on Add an indication and using your finger, you can link all your markings to create a yellow zone. This zone represents the area of the flow detected. So now the trainee can dimension it and characterize it. By displaying the flows, you can check if your trainee have correctly dimensioned the flow. Okay, let's move on the second exercises, the V-weld inspection. For this exercise, we still have a V1 block to calibrate, a DAC sensitivity block, and the weld to inspect. We will use an angle probe of 60 degrees to inspect the weld. All right, so I will not go through the calibration of the velocity under zero, but I want to show you some tools useful for the calibration of an angle probe. So I select the V1 block, the top face, and my angle probe of 60 degrees. Then I will load a pre-saved calibration, adjust the gain a little bit, and now let's find the echo of the 100 millimeter curved part of the V1 block and maximize it at 80% full screen height. All right. So here, by skewing the probe, you will see the impact of the orientation of the probe. As you can see, the signal is increasing or decreasing depending on the skew of the probe. To find the maximum of this, the amplitude of this echo, I can activate the echo dynamic functions. All right. To calibrate an angle probe, we must know where is located the index point. For this reason, I activate the digital ruler. So now, as you can see, a ruler is linked to the front face of my probe, and I can measure the distance between the front face and the edge of the V1 block. So this distance is equal to 89 millimeters. So by doing a quick subtraction, 100 minus 89, I know that my index point is located at 11 millimeters from the front face of the probe. I can now enter this value in the probe settings, and it will have a direct impact on the 3D view. As you can see in the 3D view, the ray tracing starts from the front face of the probe, and if I modify the index point value, now the ray tracing starts from mostly from the middle of the probe. The second functionality I want to show you is the display gate functions. But actually, when this option is activated, you can see on the digital mockup a red dot, which is a representation, the vertical projection of the echo triggered by the gate 1. So here I know that this echo is triggered at mostly 75 millimeters from the front face of the probe. You can also see this information in the 3D view represented by a red dot. With this function, the option to display the flows, the 3D view and section view and ray tracing, we have the possibility to know exactly what's happening inside the specimen to locate exactly the position of an echo. So we make the invisible visible. All right, so I will not perform DAC curve making, but we can obviously do it by selecting the DAC sensitivity block and by using the echoes of the side grid holes. So let's move on the weld to inspect. First of all, I will do some markings on the weld to identify both sides of the weld. Thanks to the marking tools, I can draw an A and a B on both sides of the weld. It is also possible to draw lines and crosses. All right. So I will adjust my time base to adapt it to the thickness of the weld. All right, increase the gain, and modify the position of my gate. So as you can see here, I am detecting the penetration echo of this weld. And if I move along, I scan along the weld. We can see here another indication. So let's dimension it. I will just find the maximum amplitude of this echo. All right. And now we will dimension it with the -6 dB method. So, oops. All right. So by adding some markings, I will change the color, the reference of the marking by selecting prop front, and I will add a marking to size to dimension my indication. Once we are done with the markings, I can link both crosses to create an indication. And now, if I display the flows, we can check if the TraiNDE has correctly dimensioned the flow. So we saw two different exercises with both experimental signals and simulated ones. But TraiNDE UT have much more to offer. For example, in our weld packs, most of the signals are experimental ones, such as the T-weld that you can see here on this window, display on this window. Okay, so now I will talk about the administrator section and show you what you can do as a trainer. So we will log out from the guest session to log in as an administrator. Okay, so first of all, in this first panel, the settings panel, you will be able to create sessions to help you to manage your training courses. So you can create sessions from scratch or duplicate already created ones. For this demonstration, I will duplicate the factory session. So in the settings panel, you can give a name to your session, add the date of beginning and ending of your session, and also manage the language and system of units. In the trainees panel, you will be able to create trainee profiles. So each trainee participating to your session will have his own profile, his own personal working space, and his work will be saved in this session. Finally, in the exercises panel, you will be able to create, edit, customize exercises. For example, if I select the steel plate tutorial exercise, in the edition tab, I will be able to modify the icon, give a name, create a new category, or organize it in an already created one, and give a description to my exercise. In the signal basis tab, you will find all the signal bases available within TraiNDE UT. So you can add, remove, and customize those signal bases to even more customize your exercise. In the Advanced tab, you will be able to enable or disable educational tools. So for example, if you want to put a trainee in real condition, real exam condition, you will disable all the educational tools. For example, I can disable the function to display the beam ray of the probe. And finally, in the Flows tab, you can manage the flows within your specimen to inspect. So this panel, this function is available for all the plates and 2 welds. Here, for example, we have a delimitation located at the center of the plate. If I move the cursors, I will move the location of this delimitation. So let's find out. So first of all, I will load a calibration for my straight probe, increase the gain, modify the time base. All right. Then I select my plate, and if I display the flows, we can see that the flow is no longer at the center of the plate, but now it's located in the top left corner. And if I put my probe here, we can see now that the signal has also moved. If we go in the workbench, we can see that we are no longer able to activate the probe path, the display of the probe of the ray tracing of the probes. So you can move flows, but you can also add a flow, remove one, and you can also randomize the position and the presence of the flow within the component. So each time the trainee will open this exercise, the flow will move from a location to another, and it will be there or not. So it allows you as a trainer to create a lot of different experiences. It allows you to train all your trainee on the same specimen with the same flows, but each trainee will have his own personal inspection experience. So I will finish this demonstration by quickly talk about the base maker. The base maker allows you to create your own signal base by importing SIVA data or experimental data. It is useful to create your own signal base if you want to train your trainees on specific cases. Once your signal base is created, it will be added to the signal base list of TraiNDE UT, and you will be able to perform an inspection with your own signal base. Thank you very much for your attention. I'm done with this demonstration, and I will let Benoit conclude.
Okay, so as Raphael just showed, using TraiNDE UT offers many benefits. It is fast and easy to set up. It saves time and reduced costs compared to purchasing or renting systems, probes, test and calibration blocks. The hardware is low cost and does not require periodic calibrations. Additionally, it increases practice time and the number of study cases, providing realistic handling and noisy signals. The trainer can demonstrate while the trainees work in parallel on the same cases, and the system is easy to transport. Finally, the embedded educational tools allow users to see the invisible, enhancing NDT exam preparation for better success rate. We will now open the floor for Q&A session. Feel free to ask any question you have about TraiNDE, its features and use cases. To proceed in team window, you must click on the Q&A button in the top icon bar, and it will open a menu on the right side of the window. And then you type your question and click on Ask. Okay. So I see a question. Okay. Is the training material available on your website? On our website, you can find information about TraiNDE UT and TraiNDE UT, and feel free to contact us through the website or the slide just after. I can show it now, but there are also our contact emails here.
Mm-hmm. So can you talk more about importing your own experimental signal-based characteristic? All right, so maybe, Benoit, you can spotlight my webcam, and I will show you a little bit more of this functionality. So in the admin session,
while Raphael is preparing the setup, just a quick information. That allows you to create signals with any frequency material you want. It's really just signals that you're loading. So basically, you can make the case you need. If you need 10 megahertz probe, you can have a 10 megahertz probe.
Right. So as Benoit said, you can import the signal you want. So by using SIVA, you can perform some simulations, and by extracting a text file from those results, you can import them in TraiNDE UT. And for your experimental data, if you have to export them in a very specific text file format. That we explain this on the user manuals that we provide with TraiNDE UT. And then, yes, you can import and create the signal base you want. So you can say you can put in there any materials, any frequency that you need. Yes. And if you want to, we have done this in the past, but if you want your own cases with the same signal fluidity and precise signal base, we can, depending on your component, scan it and transforming your real component into a signal base. I hope I answered your question.
There is another question. Can we add samples and defects like FSW? Is it sidewall fusion, lack of fusion, maybe, or something like that?
Yes.
Yeah, you can, since when you're creating your own exercises, since you just add signals, if the signals has this kind of defects, yes, it will be there.
Yes.
Also, in the exercises we are providing, there are many kinds of defects. There are delaminations, porosities, cracks, lack of sidewall fusion, lack of sidewall fusion. Yes. There already are a lot, but if you need another one, it can be added. Okay, so it looks like there is no more questions. So I thank you for your attention. The video of this webinar will be soon published in our YouTube channel. For more information, you can visit our website, watch our YouTube channel, and contact us directly by email. We are happy to answer any question and to help you to get most out of TraiNDE UT. And we wish you a pleasant day.